dehydration of alcohol. Now you have, remember, you can write the mechanism and get the product. What you have is sulfuric acid. Sulfuric acid will act as a catalyst, and that is where you have to start your mechanism. H plus is a catalyst. So H plus will accept electron. Now the question is, from where you will start the arrow? From the nucleophilic center. Which is the nucleophilic center here in this molecule? The answer is the lone pair of electron on the oxygen. So you start your arrow from here. Okay, what will you get? You will get 1, 2, 3, 4, 5. O, H, H with a positive and CH3. This is the molecule. It's the same as this. Okay, you get a positive charge, and see here what you have on the other side is HSO4 minus H. This is sulfuric acid. See here. I'll write the complete structure. H double bond O, double bond O, OH. So it is taking this proton. So it forms HSO4 minus. So I will write minus HSO4 minus. Okay. So this is the protonated alcohol. Now what will happen? What will happen? This will try to regain the electron. That's the next step. So it comes here. Right? It comes here. And it will give you the carbocation. Remember, this is a secondary carbocation. This is a secondary carbocation. Okay. Now what will happen? This can form a double bond. You have one hydrogen here and one hydrogen here. Right? So either this can come to this place, this is product A, or this can come from here, this is product B. So you will get a mixture of two products. You have to tell which is a major product. You have a double bond here and here, plus the double bond can be formed on the other side. Double bond here. Okay. So this is 2-methyl. Is it 2-methyl? Two-methyl pent 2-ene. One. No, it's pentene, right? So this is 1, 2, 3, 4, 5. It's pentene. Then 1, 2, 3. So it is 2-pentene. So pent 2-ene. So pent or 2-pentene. 2-pentene. Where is the methyl group? You have to put the methyl here. 1, 2, 3. 3-methyl 2-pentene. Okay. So it is, sorry, not 3, 1, 2, 3. That's right. 3-methyl 2-pentene, and this is 3-methyl 1-pentene. 3-methyl 1, 2, 3. 3-methyl 1-pentene. So this is the product when you treat this alcohol with sulfuric acid. So this is how you can write the product of the reaction. Okay. Now look another reaction. Which alcohol will give the following alkenes? The following alkenes. Now see, I'm giving you the alkene. You have to find out the starting material for the preparation of these alkenes. Number 1. Number 2. Yeah. Now try it out. All of you write and find out what is the starting material for the preparation of these alkene, the corresponding alcohol starting material. You have to write the corresponding alcohol starting material. What is the starting material? You can do the reverse reaction. Add H2O into this molecule. Add H2O. Double bond you can break. You can add the H2O on this side or this side. Or you can add H2O here and here. H on this side. Okay. Now remember, we are interested only in this product. No other product. That is the most important thing. Okay. We are interested only in this product. Suppose we take this compound and treat this with sulfuric acid, H2SO. Okay. Now what will you get? This will be protonated and you will get this product. You will get this product. Suppose you start with this alcohol, you will get this plus, and now see, you have to form the double bond. Now the double bond formation can be from this side, or from this side. See this. If it is formed from here, you get 3 products. You get 3 products. This one. That is by removal of proton by A. So this is from A. Now, if this is what is occurring, you will get our desired product. Our desired product. See here. This is what we actually want. And the third product is, you get the product from the removal of double bond, formation of double bond on the side chain. Now in this one, so this is by B and this is by C. By C. Now in these 3, now you have to decide which is the major product. The major product is the one which is formed by, we have seen that by Zaitsev rule. Zeitz rule. Now what is that? What is Zeitz rule? The alkene with maximum substituents is getting formed. Alkene with maximum number of alkyl substituent is a major product. Alkyl substituents is a major product. Major product. Okay. Now, if that is a major product, now which is the maximum number of alkyl substituents? It is this product. See here. Here you have an alkyl group. On the double bond, you have one alkyl group. This also is alkyl. This is also alkyl. This is also alkyl. So this is the major product. And this is the second largest product. This is the most minor product. So we are not interested in this method. We want this as the major product. So what we have to do? We will have to take this alcohol. No, not this. This we have taken. We have to take this alcohol. If we have this alcohol, what we will get is this. You will generate this carbocation. See here, you form a carbocation here by removal of H plus. See here, same mechanism, and then this will go, and you'll get this carbocation. Now you have two choices. Look here, there is one H here, one H here. You can get two products, one, and this is two. Okay, now the major product. Look at the, decide the major product. This one. See here. How many substituents on the alkyl group? One on this side, second on this side, and third. And the fourth substituent is hydrogen. Okay. Now you get the second product from this side. This plus double bond on this side. Okay. This side. Now here, how many substituents on this double bond? This is one alkyl substituent. On this side you have hydrogen. This side you have hydrogen, and here you have a second side. So you have three alkyl substituents here, two alkyl substituents here, and therefore this is the major product, and that is what we want. Clear? So this is how you have to decide the product. Clear? Now let us go to the next one. Number 2. Let's see whether we can do the second one. Yeah. Try it out. This is what is needed. So again, do the same thing. I think you can do it. You will do it. Okay? That you can do by yourself. Decide in the same way which compound will be formed. Now, did we discuss oxidation of alcohol? I don't know. I don't remember. Did we discuss that? I think we have discussed oxidation of alcohol. Yeah. If you take an alcohol, oxidation, if you take an alcohol, any long chain alcohol, CH2OH, if you treat this with chromium trioxide and acetone, CrO3, in acetone is an oxidizing agent. Chromium trioxide is an oxidizing agent. Okay. Or sodium dichromate in water, or Na2 Cr2O7 and water and sulfuric acid, not water. Sodium dichromate in aqueous sulfuric acid, H2SO4. You will get the corresponding acid. Corresponding acid will be formed. Okay. You will get the corresponding acid. If you are using a secondary alcohol, so this is a primary alcohol. This is a primary alcohol. If you are using a secondary alcohol, say for example, I take this compound. You can take any alcohol and then treat with the same reagent like this. Now this alcohol group will be oxidized, and what you get is the ketone. Remember that secondary alcohol will give you the ketone. Okay, this is the problem. And also remember, tertiary alcohol will not be oxidized. Tertiary alcohol will not get oxidized. Okay, now suppose I have this compound. I want to prepare this compound. Prepare cyclopentanone. This is called cyclopentanone. From oxidation of a corresponding alcohol, how will you prepare? By oxidation, you will get a secondary the ketone. So, what will be the corresponding alcohol? This is going to be the corresponding alcohol. This compound on oxidation with Na2Cr2O7 in presence of sulfuric acid, you will get cyclopentanone. Okay, that is now another reaction is conversion of this compound into ethers. Okay. Okay, that will come. Anyway, we are going to take up ethers. We will take. Now let's look at the reactions of phenols. Reactions of phenols. What are phenols? You know what are phenols? Aromatic compounds. Aromatic compounds containing OH2. So this is simple phenol. Okay. Simple phenol. Now you can have, I can put a CH3 on the OH. So that is called cresol, orthocresol. Orthocresol. Cresols. And then if CH3 is here, you will call it as meta. If the CH3 is here on the para, so you have ortho, meta, and paracresol. So what I can do is I can put the CH3 from the center. I'll remove this. I'll remove this from here. Now, to make it easy, see here. I'll put the CH3 on the. If the CH3 is here, you call it as ortho. If the CH3 is here, you call it as meta. If the CH3 is here, you call it as para. Clear? Okay. Now you can have alcohols with two OH groups. Two OH groups. Again, let me repeat. Let me put the OH here. Now it is ortho, two OH group on ortho position. You call it as catechol. Catechol. So CHOL. Sorry. CHOL, catechol. And if it is meta, you call it as resorcinol. And if it is para, you call it as quinol. Called as quinol. Okay. So these are some of the. Similarly, you can have trihydroxy. You have different names for that also, right? Now let us look at the preparation of phenols. Phenol preparation. Preparation of phenols. This is one of the compounds which is manufactured in very large amount and they all over the world. You have a lot of application for this, use for phenol. So preparation you can have, very large amount it is found, and the different methods are named after each company which is manufacturing it. That is the interesting part of it. So there is one, the first process is Dow process. One of the methods is known as Dow process. Dow process, you start with benzene. Dow process. You start with benzene and convert that into phenol. Direct conversion is not very easy. Direct conversion of phenol is not pretty easy. So what people do is, they do an easy reaction. That is, they treat this with chlorine in presence of FeCl3. Now we have studied this in our aromatic chemistry. This will give you chlorobenzene. Pretty easy reaction. This is pretty easy reaction. Now what you have done is you have made this bond has become compared to CH bond. See here. Compared to CH bond, this bond is weaker. It is more. The electrons are more attracted towards the chlorine. But in the case of CH bond, the electrons are close to the carbon. Now, if you treat this with sodium hydroxide, aqueous sodium hydroxide, aqueous NaOH, at high pressure and high temperature, 350 degrees Celsius. Note that. 350 degrees Celsius and 200 atmosphere. It's a pretty high pressure. 200 atmospheric pressure. Now you understand, it is very difficult to introduce an OH group. Substitute the Cl by OH. Remember, OH is a nucleophile. OH is a nucleophile and electron rich. So this has to come here and take it off. And remember, Benzene ring is already having a lot of electron. This is also having electron. So nucleophilic substitution is very difficult. That is the reason why you require high temperature. So this is a nucleophilic substitution. Nucleophilic substitution. And you end up with your phenol. Of course, this is used for high-tech reaction. High technology is involved. You have to have high pressure, high temperature. You should have facility for that. Okay, good reactors which can withstand all these pressure and temperature. Okay, but only advantage of this reaction is you get almost a good amount of the product. Nearly 100% yield is obtained. That is something very good for this. Nearly 100% yield is being. So this is right from 1928. This process is still being used by the company called Dow Chemicals, one of the multinational company which is based in US. They are manufacturing very large amount of phenol, and probably they should be very good exporters of this compound. The second process is Raschig process. Raschint. IG, sorry. No, N is not there. Raschig process. Okay. Phenol manufacture is Raschig process. And this involves treatment. This is I should say, it's a catalytic process where you have simply introducing, again, you are doing the same job. Job is just the same. Instead of using chlorine, you are using a cheaper reagent, HCl. And what you're doing is, you are oxidizing HCl with atmospheric oxygen. HCl, if it is oxidized, using atmospheric oxygen and in presence of CuCl2 and FeCl3. CuCl2 and FeCl3 catalyst. At 250 degrees Celsius, you will get chlorobenzene. Same method is just the same. Okay. It is then you treat this with steam, high temperature steam, superheated steam at 425 degrees Celsius. Superheated steam. At 425 degrees Celsius. Again, high tech. Achieving this is pretty not very easy for us. Simple laboratory. So you will get your phenol out. So these are the major process by which phenol is manufactured all over the world. Okay. Now let us look at the chemical properties of phenols. Acidity of phenols. Now phenols are acidic. Phenols are acidic. What is the meaning of that? If you react phenols with bases, I take a phenol and react with sodium hydroxide. It will give you the phenoxide ion. And you remember Phenoxide ions can be stabilized by resonance, corresponding Na plus, sodium phenoxide plus water. Okay. So if you take a little amount of phenol insoluble in water, phenol is insoluble in water. Now you are adding sodium hydroxide, it becomes soluble. Why? Why? Because it forms sodium phenoxide, which is any sodium salt. Any sodium salt is soluble in water. Okay. So it will very easily react with the. But remember, if you do the same reaction with sodium bicarbonate, a weak acid, no reaction. Don't forget it. If you are using a weak base, I write the word weak base, you will not get a